The first night feels like withdrawal. You set your phone down 2 hours before bed, and immediately your hand reaches for it. The phantom buzz, the urge to check just one more thing. Your mind invents reasons why this particular evening requires an exception. This restlessness isn't weakness. This is your brain recognizing that something it has come to depend on is suddenly absent. But beneath this surface discomfort, something extraordinary is occurring. Deep within your retina, in layers of tissue thinner than a human hair, your photoreceptor cells are finally catching their breath. For months, perhaps years, these cells have been bombarded with light at times when darkness should reign. Rods and cones, the cells that allow you to see, have been working overtime. Now, in this unexpected darkness, a different type of cell activates. Melanopsin-containing ganglion cells, which have nothing to do with vision and everything to do with time, finally send the signal your brain has been waiting for. These cells are exquisitely sensitive to blue light, the exact wavelength your screens emit most powerfully. They create a direct pathway to your hypothalamus, to the master clock that orchestrates your entire circadian rhythm. Within 90 minutes of your last screen, something shifts. Your pineal gland, which has been suppressed all evening, begins producing melatonin earlier than it has in months. You might feel more alert right now, restless even, but your biology is preparing for something deeper. Your eyes have finally received permission to signal night. Days 2 and 3 bring what feels like punishment for a choice you thought was healthy. Your eyes feel strained, almost more tired than before. You reach for your phone habitually, each time remembering your commitment. Sleep is better, yes, but the evenings feel empty. Irritability creeps in. Yet, this discomfort has purpose. Your retinal cells are undergoing profound detoxification. Every time light hits a photoreceptor, it generates free radicals, unstable molecules that damage cellular machinery. Screens create a relentless assault of these reactive oxygen species. Your retinal cells contain more mitochondria than almost any other cell in your body. They burn energy ferociously, and that combustion creates waste. For the first time in recent memory, these cells can clear the backlog. Antioxidant systems, overwhelmed for so long, finally catch up. Damaged proteins get tagged and removed. Mitochondrial membranes repair themselves. It's cellular house cleaning, and like any deep cleaning, it creates temporary chaos before clarity emerges. Something else is changing. During screen time, your blink rate drops by more than half. Instead of 15 to 20 blinks per minute, you blink 7 times, maybe less. Your tear film, that intricate 3-layered coating protecting your cornea, never fully regenerates between blinks. 2 days without evening screens, and your natural blink rate returns. Your tears, composed of oil, water, and mucus in precise ratios, rebuild their protective architecture. The burning sensation you didn't realize was constant begins to fade. Defense systems are coming back online. Within 7 days, something astonishing becomes measurable. You fall asleep faster. Not slightly faster, but 14 to 20 minutes faster than you did a week ago. Your sleep architecture, the precise stages your brain cycles through each night, has fundamentally shifted. This change originates in your eyes. Behind your retinas, buried deep in your hypothalamus, sits a cluster of neurons called the suprachiasmatic nucleus. This is your master clock, the conductor of every circadian rhythm in your body. It cannot see the sun directly. It relies entirely on signals from your eyes, specifically from those melanopsin cells that have been receiving blue light at all the wrong hours. For months, your SCN has been confused. Light at 10 p.m. signals midday. Your master clock tries to adjust, tries to reconcile these contradictions, and fails. The result is a circadian rhythm that drifts later and later. 7 days of darkness before bed, and the confusion resolves. Your SCN receives clear, consistent information. The simplicity allows synchronization. Your slow-wave sleep increases by 20 to 30%. Your REM sleep arrives on schedule instead of being cut short. But the transformation extends beyond sleep stages. Cortisol, your primary stress hormone, should decline throughout the day. Evening screen light keeps it elevated when it should be dropping. 1 week of screen-free evenings, and the pattern corrects. Your cortisol now drops appropriately, 2 to 3 hours before sleep. Your eyes aren't just resting, they're recalibrating your entire relationship with the 24-hour day. By the second week, if you could examine your retinal tissue under a microscope, you would witness cellular resurrection. Your photoreceptor cells operate through an elegant molecular dance. They contain photopigments, proteins that change shape when struck by light. This shape change triggers the neural signal that becomes vision, but the process destroys the photopigment molecule. It must be regenerated constantly. Constant screen exposure depletes photopigments faster than your body can regenerate them. Your vision doesn't fail completely, but it operates below optimal. Contrast sensitivity declines. Your eyes struggle in low light. Colors seem less vibrant. 2 weeks without evening screens, and the regeneration cycles complete properly. Rhodopsin in your rods reaches levels you haven't experienced in years. Photopsins in your cones rebuild their populations. Research documents measurable improvements in contrast sensitivity, 15 to 25% increases that translate to sharper, clearer vision. The changes extend deeper. Your retinal ganglion cells have been operating under chronic stress. The blood-retinal barrier, which protects these delicate cells, strengthens. Blood flow patterns normalize. During screen use, bright light causes vasoconstriction, reducing oxygen delivery. That constriction releases. Your dark adaptation improves dramatically. This is your eye's ability to adjust when you move from brightness to darkness. 2 weeks of proper recovery time, and you can navigate a dark room within minutes. The effects ripple outward. Eye strain headaches disappear. Your ability to focus during daylight sharpens. These aren't minor adjustments. These are fundamental shifts. Around week 3, you notice something different about your energy. It's not that you have more of it, though you do. It's that the pattern has changed. You feel naturally tired at appropriate times. You feel naturally alert in the mornings. This shift is the result of a hormonal transformation that originates entirely in your eyes. Melatonin does more than make you sleepy. It orchestrates repair throughout your body, regulates your immune system, acts as one of the most powerful antioxidants your cells produce. But screen light doesn't just delay melatonin production, it reduces total output by more than 50%. 3 weeks of darkness before bed, and your pineal gland remembers its full capacity. Those intrinsically photosensitive retinal ganglion cells in your eyes are most sensitive to light at exactly 460 to 480 nanometers. This is the blue wavelength. When these cells detect blue light, they send inhibitory signals directly to your pineal gland. You don't need to consciously see the light for it to suppress your melatonin. In darkness, the signals stop. Your pineal gland produces melatonin in waves that build throughout the night. This rhythm, restored after 3 weeks, does something unexpected. The melatonin circulates back to your eyes, where it acts as a protective antioxidant for the very retinal cells that triggered its release. The benefits extend beyond your eyes. Memory consolidation during sleep improves. Your immune system regulates properly. Your eyes don't just see the world, they orchestrate your biology's relationship with time itself. Perhaps the most profound changes occur in places you cannot feel. At the back of your retina, in a layer called the retinal pigment epithelium, your cells battle against a substance called lipofuscin. This is cellular garbage, the accumulation of proteins and lipids your cells cannot fully break down. It builds up over decades, driving age-related macular degeneration. Blue light accelerates lipofuscin formation. The high-energy photons create reactive oxygen species that damage cellular components. Every evening spent staring at screens adds to the burden. Your retinal pigment epithelial cells try to clear this waste, but they're overwhelmed. 30 days without evening screen exposure, and the accumulation rate drops significantly. Your cells finally clear debris faster than it forms. This doesn't reverse existing damage, but it changes the trajectory. Your future vision is being preserved in ways you cannot yet perceive. Something else is recovering. Inside your eyes, surrounding your lenses, sits the ciliary muscle. This muscle changes your lens shape to focus. Screens force this muscle into chronic near focus, creating ciliary spasm. The muscle forgets how to relax. 1 month of evening freedom, and the tension releases. Your focusing flexibility improves. You can shift from reading to distance viewing without the blur. Even your intraocular pressure normalizes. Elevated pressure is a primary risk factor for glaucoma. 30 days of reduced evening screen stress and the pressure drops into healthier ranges. Your eyes carry ancient blueprints for self-preservation. Given the smallest opportunity, they activate defenses and rebuild what was breaking down. Around day 30, you realize the change isn't just in your eyes or even your sleep. Your energy feels different, more stable. The afternoon crashes have disappeared. You wake without the foggy disorientation that used to require coffee to penetrate. Mental clarity arrives earlier and lasts longer. This is your metabolism remembering its original programming. The connection runs through your eyes to your entire endocrine system. Your circadian rhythm, now properly synchronized, governs far more than sleep. It regulates glucose metabolism. When your master clock is confused by late-night light, your body struggles to process sugar efficiently. Insulin sensitivity declines. 30 days of proper dark exposure before bed, and insulin sensitivity normalizes. Your body processes glucose efficiently again. Blood sugar no longer spikes and crashes unpredictably. This happens because your liver, muscles, and fat cells all have their own circadian clocks, and all take their cues from the master clock in your brain, which takes its cues from your eyes. Your cortisol awakening response now happens on schedule. This gives you genuine morning energy instead of sluggish grogginess. Even your hunger hormones have recalibrated. Leptin and ghrelin, both operating on circadian rhythms, find their rhythm. You eat when you're actually hungry. Inflammation markers throughout your body decrease measurably. This happens because quality sleep is anti-inflammatory, and quality sleep requires proper light-dark cycles. You thought this was about screens, but it was always about your eyes being the gateway through which your body knows what time it is. Something unexpected happens that you almost don't trust. Colors seem richer. The world appears sharper. Edges more defined. You wonder if it's psychological, but it's not imagination. Your visual acuity has genuinely improved measurably in ways that optical science can document. Contrast sensitivity, your ability to distinguish subtle differences in shading, has increased by 15 to 20%. This isn't about seeing smaller letters on an eye chart. This is about seeing the world with the resolution your eyes were designed to deliver. You notice textures in tree bark you'd stopped perceiving. Reading is effortless in lighting that used to strain your eyes. The neural processing behind this happens during sleep. Your visual cortex consolidates and optimizes its connections during deep sleep. REM sleep specifically enhances visual learning. 30 days of improved sleep architecture means 30 nights of your brain, strengthening its visual processing networks. Digital eye strain syndrome has resolved. The blurry vision after long work sessions. The double vision when you're tired. The difficulty switching focus. All of it originated from exhausted eye muscles and overstimulated retinal cells. All of it disappears when your eyes get proper evening recovery. Your accommodation amplitude, the range of focus from nearest to farthest, expands. Your ciliary muscle has released its chronic tension. Even your tear film has transformed. The 3 layers exist in optimal proportions again, reducing light scatter and glare sensitivity. Your night vision astounds you. Stars you hadn't seen in years emerge. This is rhodopsin regeneration, dark adaptation restored. Your eyes aren't just healthier. They're performing at a level you'd forgotten was possible. Behind every symptom, beneath every improvement, runs a common thread. Inflammation. Chronic low-grade inflammation that blue light triggers in your retinal tissue and that cascades throughout your body. Understanding this mechanism reveals why such a simple change creates such profound effects. Blue light penetrates deep into your retina and generates reactive oxygen species in your photoreceptors. These free radicals damage cell membranes, mitochondria, even DNA. Your immune system detects this damage and responds with inflammation. Cytokines like interleukin-6 and tumor necrosis factor alpha flood the tissue. When blue light exposure is brief, daytime only, your immune system cleans up and the inflammation resolves. But when screens extend that exposure into evening, the immune response never ends. Inflammatory proteins remain elevated. Cells exist in constant stress. The blood-ocular barrier becomes permeable, leaky. 30 days without evening screens, and this cycle breaks. Inflammatory markers return to baseline. Your immune system, recognizing the persistent threat has passed, finally stands down. The blood-ocular barrier restores its integrity. Something else increases in the absence of chronic inflammation. Brain-derived neurotrophic factor, a protein essential for neuron health. BDNF production rises during quality sleep and falls during sleep deprivation. It supports retinal ganglion cells and optic nerve function. 30 days of restored sleep means 30 nights of elevated BDNF. The eye enjoys what immunologists call immune privilege, special protection from inflammatory responses. But screens erode this privilege. 1 month of darkness before bed, and the privilege is restored. The inflammatory feedback loop that perpetuated itself, making each day's damage worse, finally ends. By day 30, you realize this transformation extended far beyond your eyes. Your relationships have improved. Your productivity has increased without additional effort. Your mood is more stable. The thread connecting all of these changes runs back to those first evenings when you gave your eyes what they'd been requesting for years: darkness, rest, time. The improvements in cognitive function are measurable. Reaction time, working memory, sustained attention, all require quality sleep. Your prefrontal cortex, responsible for decision-making, functions optimally when sleep is deep. Your amygdala regulates appropriately when REM sleep is adequate. Your stress resilience increases because your HPA axis recalibrates during proper sleep. Creativity and problem-solving improve because REM sleep facilitates novel connections between information. You wake with solutions to problems you couldn't solve the day before. This isn't magic. This is your brain doing what it evolved to do. The longevity implications are profound. Reduced eye disease risk from lower lipofuscin accumulation. Reduced dementia risk from improved sleep quality. Reduced metabolic disease from restored insulin sensitivity. These are fundamental protections of your health span. The humbling realization is how simple the intervention was. No medication, no expensive treatment, just honoring an ancient relationship between your eyes and darkness. Just acknowledging that your biology evolved to expect light during the day and darkness at night. This isn't a 30-day challenge. This is revelation of how you were meant to live. Your eyes carried this wisdom all along. They were simply waiting for you to listen. Not because you've earned restoration, but because your biology is designed to return to balance when given the chance.